So we'll start. Okay. So hi. So you know me and you know all my friends from all across the solar system. They are here with me. Last week we saw of what has happened in the Mars 2020 rover. So how it has get there, what is happening now in the experimentation, all these things we saw last week. And now today we are going to see something little more about what is going to happen in the future. So what did we see in the last week? We saw some of the interesting components, some of the interesting experiments that the Mars 2020 rover is going to do. It's called Perseverance. So what is it going to do? What is it going to take photographs? How are things going to happen in there? All these things we saw. Next, we saw how it started its journey in 2020, and it has reached there on February, there at Mars. We saw how the communication happens between Mars and Earth, because they are almost little far away now, because they earlier used to be a little close by. Now it has gone little far because we are running faster than Mars every day. And how is the communication happening using all these spacecrafts that are in the deep space? So all the networks of deep space satellites, and how we are getting signals day and day in. So little by little, how it is getting collected, and we are getting all the information in one particular day. That is using technologies related to microwave architecture. And we saw the photographs taken by the spacecraft when it is getting landed on the surface of Mars, and how there is a recent video, about a 3.5 minute video of how the spacecraft got landed. This was released on 4 days back on February 24th. And all the photographs that closer to the surface of the rover's tires and all these things we saw. So today's episode is about how are we landing on Mars? What is the technology that we use? What is something that we already know, but we are yet to give it a name? So that is what we are going to see today. So you saw this image already, right? So we started sometime on the last year on the month of July, and we reached there in the February month in 2021. What was the method that they used to travel such a long distance? Can anyone tell me?
Question again, sir?
We started from Earth and we sent the spacecraft out into the space, and it reached there in another 7.5 months to Mars. What did we use? Did we use rocket? Did we use anything else? What did we use?
A rover?
Yeah, we used a rover for landing purpose. We have landed it there, but from Earth, what was the vehicle that carried it? எதுல கொண்டு போனாங்க இங்க இருந்தாங்க?
Spacecraft?
Okay, spacecraft. Okay. Next, apart from spacecraft,
Rocket, sir, that has a shield on it.
The specific name of that, sir?
I'm asking about the method. That is, what is the method they use? Okay, spaceship, rocket, all these things are very common, but once you start, how do you say this is fast or this is slow, right way, this is the wrong way? How do you know? How does that happen? Any guess? Okay, what is very famous for Newton? What did Newton discover?
Gravity.
Gravity, correct.
Gravity.
But what is gravity? What really is gravity? You know what really is gravity? Then I'll tell you what is gravity. So gravity is something that keeps us all.
When we put something up, then if it falls down, it is known as gravity, sir.
So that means gravity.
Okay, everybody is right.
It's
But
the force of Earth.
it is a force that keeps us in the Earth, and it is the force that keeps the moon going around the Earth. Right. But what is that to do with Mars rover and travel? Yeah, what does it have to do with Mars rover and Mars spacecraft? Do you know what is that?
Is there gravity in Mars? It was discovering.
No, it is not that. So it is not. We already know there is some kind of gravity in Mars, but in between that, we know there is something. That is what we are going to see today. So gravity is something that is keeping us in the ground, so that if we jump up, we don't fly into the sky. So that is a very common thing that has been there throughout our Earth, and this is something that also keeps all the planets in the same place. So when the planets are trying to go, they go around in a very big circular orbit. So if I stand and I think I'm jumping up, I don't leave the Earth and I'll fall back the Earth. So it is not like I'm running behind the Earth. So the Earth and the all the objects are bounded. That is, it is all in the same place because of the act of gravity. And this is the reason why we have bigger objects that are going around the circle. So we have Earth, we have the moon going around the Earth, Earth going around the sun going around the center of the galaxy, and all the galaxies going around some kind of a center which we don't know where is the universe. So this was discovered by Newton in the year 1687, and he was the one who formulated all the three gravitational motions, the laws of motion. He is the one who started. So I have written something here. You have, can someone read me what is the three forces or three laws of motion?
A force is needed to change motion. Acceleration is proportional to the resultant force. Every action has equal and opposite reaction.
Okay, everybody knows the third one. That is, every action has equal and opposite reaction. So what does that third one has to do with rocket? What is rocket has to do with the third one? Every action has an equal and opposite reaction.
Can you explain that, sir?
So if I start a rocket, okay, there is something coming out from the back of the rocket. What is that?
Some parts of that,
What is that?
some parts of the rocket.
It is actually rocket fuel. So it is a combination of some kind of fuel that is made uniquely for the rocket to go front. So the when we push the rocket in down, I mean when you push the fuel, that is the rocket fuel down, the rocket is going up in the forward motion. So this is called the gravitational law of force that is happening on the opposite side. That is, we are trying to escape the gravity of the Earth. That is, it is around 11.2 meters per second. So if we escape that, we have to push it in so hard that out of which we can able to get out of the gravity of the Earth. So like that, all these things was managed in such a way. So if once we leave the Earth, what is that binding us? We leave the gravity of the Earth. What is keeping our okay? We are going around in a flying bus across our solar system. What is guiding us? Who is guiding us? Who is the
So
driver?
the question again.
Who is the driver of our bus? Who is the driver of our flying bus?
Sun.
Yes, correct, exactly. So the sun is something that is very big, that is very massive. Okay, so that is the one which is guiding us through all the planets, and it is trying to take us from Earth to Mars to Jupiter to Saturn to Neptune to everywhere it knows, because it is keeping us in the gravity of the field. So that is what first person to discover, that is Newton, thought through. That is, every planet is bound by some kind of a gravity which is of bigger mass, that is bigger than the planet. So for us, sun. Next, someone called Einstein came. Einstein said there has to be something which is even more consuming. That is, it has to be even more imaginative than Newton. So what he said, there is something called space-time. Space-time, when something is moving around in space, it warps the time around it. So Newton was not there, because Newton was about 230 years before him. And Einstein said if someone has to prove it, it will be the revolution, that it will create so much of interesting things in life. And everybody thought, no, 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 this is all very wrong. We don't like to approve. Einstein is only making all these things. We know Earth is round and the space is flat. So everywhere you see around Earth, the space is going around and flat in every direction. There is no such thing as space time. There is no bending of time, he said. So every other scientist said. So Einstein said an experiment. He made sure that there has to be some way to prove it. So what he did, he started devising some experiments wherein which we'll fix a bigger mass and we'll put a bigger object to test it out. So the first thing he did was he sent two of his friends to an expedition, that he sent them deep into the African continent, and on the coast of one of the nations of Africa, he asked them to set up a telescope and look at the sky. This was something which he said, when you look at the star from the nearest region, that is our sun, we look at it at a straight angle, but whatever that is behind the sun will get bent due to our gravity. He said the earth's gravity and sun's gravity make sure that light get bent. Everybody said it is all not possible. So what he did, he sent his two of his friends to a little island across the Africa, and they set up a telescope and they started taking photograph of an eclipse. When the eclipse happens, it was completely dark. So whatever light was behind the sun was able to be visible. So when they compared the light from before and after the eclipse, they found that there was a small shift in the light between the star behind the sun. So some billions and billions of kilometers behind the sun, there was a small 2.5 distance. That is, it was light year distance that was measured then from a deviation of the normal time. So this is how they. And later, after years and years, scientists also thought there has to be another way. So next thing they did, they started taking photographs of a black hole. So whenever a sun or whenever other star passes through a black hole, there is a gravitational lensing. So you can see here, there is a small change in light across a small black hole. They started making these measurements and they found that whatever that is bending it, it has to be a very big black hole. So sun is very small in bending light and time. Neutron star little more bigger. Black hole is so massive that it can bend everything around it, space, time, everything. And finally they said this is true, that's why we are going around our sun, and this is why moon is going around us. So that's why time is different between us and any other object across the entire solar system or entire universe. So all these things made sure that we can use gravity for our next fuel. So if we run out of fuel when we go into the upper atmosphere, we can use it efficiently. How is it used? We can use it for assisting. So gravity assist is the method by which a spacecraft from Earth, that is the Perseverance Mars rover spacecraft, left the Earth, and for about 3 months it was using the gravity of the Earth for a shorter period of time. It was going around and round and round. It was making bigger and bigger circles, and by the time it was very fast enough, they fired a retro firing rocket. That is, retro firing is it was in the opposite direction and it got flung out. So it massively jumped out of the gravity of the Earth and it went so fast. So the fast was so fast that it was almost to the speed of sound. So that's what we are going to see. What is that speed of sound? What is that Mach sound? So by this you can also create artificial gravity. So you can see there is a small guy who is throwing a red ball here. So when he throws, actually he is in a circular room that is going around in the International Space Station. So whatever he is throwing up, it is constantly falling back into his hands. So like that, everything that is going around our Earth is in constant acceleration of falling to the surface. But because of a little bit of small tiny force, that tip kind of a very small force, it is going around and round and round and never falling into the Earth. So that is why they use the same method to push the Perseverance rover spacecraft deep into the space. And this is how even our solar system started its life. So I'll take you to the first time. So after Big Bang, we had a lot of floating dust and smoke in our entire universe, and slowly they started falling into the same place. So they slowly started becoming bigger chunks of rocks and stones and everything, and finally they become a very massive planet like our Earth, Jupiter, Saturn, all these things. And then some of them, when they are not very close to the sun, they become a very small rocks. These rocks became comets and asteroids that are far away from our Earth. So that's what we know. So all these things is because of gravity. Not only gravity, there is also one more person who is needed here, that is comparative gravity. That is between Newton and general relativity, that is Einstein's gravitational equation. We came to know that whatever we are trying to send into space, there is some kind of elliptical motion, that it is going around in an elliptical motion, and it will fall back into the speed with the inertial law of motion. So these are all little complicated, much easy if you follow this very small example. You know that we have morning and evening, there are low tide and high tide. I told you, remember, when we are in the earth, the moon is keeping us in a tug of
It's
war.
there in my social studies.
Yeah, it is there in your social studies. So when you are in the earth in the morning time, there is a high chance that you are in the low tide region because the moon is not directly in front of you. But when you are in the night time, you are in the high tide region. That is, the earth's water is getting pulled by the gravity, so the water is very loose, it is not sticking to the surface of the earth. So this makes sure that every object in our space. Yes, someone has a question, tell me.
How does dust become into rocks?
How does dust become into rocks? It is like adding a little bit of water. It is like adding a little bit of water to your sand. So if sand is something that is getting binded by water, it becomes a sand mold, right? It becomes a sand mold. Gravity is something like a water, so it tries to flow in every direction at equal time. So when all the rocks are very strong, they are get binded to each other and they become very strong. I will also tell you what happens if you don't have gravity. Okay, so if there is no gravity, if the earth does not have gravity, will we spin? Can earth spin without gravity? Possible?
No,
What will happen?
no, sir.
What will happen?
Mm, the pressure would increase, sir.
I think I've mentioned it here. So without the force of gravity, there is no gravity at all. The pressure that is inside the core, that is all the molten lava, all the magma inside our earth, start to spin erratically. It will start to spin so much, and it will break the entire earth into pieces, shatter it into pieces. Yes, Samyukta, what you have as a question?
A simple question, sir. Which fuel does a rocket use to move?
It is a special kind of fuel, that is, it is made up of uh, about 90-95% of petroleum based fuel, that it is completely combustible, so it is called white form of petrol, and it is the same fuel that is used by even our aeroplanes. But the combustional nature of the rocket fuel is slightly higher, so it has to burn something like 3 tons of fuel every second. So 3 tons is
The
like,
compression is higher, sir.
compression is higher, yeah. If 3 tons is like putting 3 elephants on top of each other. So that much amount of pressure will be there, it will be kept, and it will be sent through a small nozzle, that is the shape of the
Then
space.
a rocket uses a lots of fuel, no, sir.
Yeah, something like it has the total size of the rocket is about uh, 1/8 of its size is the only the spacecraft. That is the very small, that conical thing on the top. That is the one you see here. This is the top end of it. So
Okay, sir.
all the remaining things are about that 7/8 of it is completely made of fuel. So it is all the rocket
Will
fuel.
drop down.
It will fall back into the Earth's gravity, and it can be recovered for the future use. Okay, so I will take you across why do we need to know all this physics and chemistry for all these reasons? Because we are right now in a place where everything is bounded by our fundamental understanding of nature. So nature has created the planets round. We don't have a rectangular planet or a triangular planet, because everything that is bounded to each other is through the law of nature. That is, circle is the most easiest thing to make, and all these things was the reason we have sent a spacecraft in a form of a conical or a circular shape on the front, because it was two halves. One half was a semicircle, another half was a semicircle. So this is one half of it, that is the other half of it. So they are both sent in like an ice cream bowl, and they are sent it there. And once it enters the gravity of another planet, so from Earth it left and it was caught by the gravity of the sun. Next it had almost reached the gravity of the Mars. So when it reaches Mars, what happens? So from it started slow, it gained a lot of speed, it became faster than the sun, and then what happens? It has to come slow or it has to go fast when it reaches?
Question, sir?
I started very slow from the Earth. I gained a lot of speed, and I was almost equal to the speed of the sun. And then I was almost getting close to the Mars. And will my speed be slow or will my speed be fast?
It will be slow, sir.
Yes, because the time in which you are entering the gravity of the another planet, there is a kind of a medium in between. That is, can you tell me what is this?
Which, sir?
One on your right. Someone is firing a bullet.
Inside the water.
Okay, and what is this?
It's a thunderstorm.
So what is this? So this is something that I told you last week, something about different forms of medium. What is this medium? What is this medium?
Sir, a clue?
This is very light medium. This is a very dense medium. Density is more here.
Don't know, sir.
This is something to do with the medium of air and then this medium of water. So this air and water are compared here. And one important phenomenon is, this is talking about the medium of air with light as an example. This is medium of water with sound as an example. So why do you need this? Because last week Samyukta asked me what is the supersonic, subsonic speed of a fast spacecraft or a jet. So when you compare two things, you need to know which medium it is traveling. So we know that the light travels faster than a sound, because that is the nature in which we are working. So for comparative reason, we are taking the sound as the base, and we are dividing, or we are taking the object speed and dividing it by the speed of sound, so that we know what is the proportional speed of it. So if it is much faster than the sound, it is supersonic. If it is much slower than the sound, it is subsonic. If it is almost to the speed of sound, it is transonic. But when we send a spacecraft, we are sending it in a hypersonic speed. It is so fast, that is even faster than the sun. That is how it escapes the gravity of the sun, and it is trying to reach the what do you say, the surface of Mars, and it has to become 1 and minus 1. So what they use, they use the media in between, that is the medium in between, and they try to from 300,000 or 300,000 million meters per second, that is the speed of light. They are trying to match it to 340 meters per second, that is the speed at which they are trying to land a spacecraft on the surface of Mars. So that is a way in which they are doing so much of mathematics and calculation to land there. So that is how last week we saw they landed the Perseverance rover there, and they used a kind of terrain guidance system to take photographs, and within a matter of seconds they were able to match and try to send it there. So that's what we saw. So all these things we saw was related to the navigation system that we had recently saw as a complete video. I will send you a WhatsApp link of what we can able to see there in detail. So this is more or less the things that we are getting from Mars. So we have got a very good panoramic shot of the entire surface of Mars in the last week. So we are starting to explore it one by one, and probably we are going to start the experiment of flying that small helicopter that Mars Ingenuity helicopter in the next couple of weeks. And this is what we saw. I will try to explain more on space time and gravity in the upcoming classes, because it is going to be more interesting once we started seeing about black holes, neutron stars, and all these things. So you'll get to more see that later. So that's it for today. If you have any questions, you can ask me.
Sir,
Yes, sir. Yes, Amita.
sir, can I leave now, sir, because I have another call from school.
Okay. Thank you.
Thank you, sir.
If anyone else has
Bye,
any
sir.
question, you can ask me.
No, sir.
No, sir.
Is the helicopter on the rover or not on the rover?
It is already signaling from the rover. It is there in the rover, so it is expected to fly in the uh, first week or second week of May 2021. So sometime in the first week of May, or Nitin, what was the question again? Okay. Else has any question? No questions? Okay. So that's it for today. Tata. Bye.
Bye, sir.
Bye bye.
Sir.